Okay. My name is Chris Dick. I'm a product manager here at GRIDiant. I helped put together this product. It's for, of course, demand response. And we're trying to get, in a sense, we're trying to get more out than what we're putting in. And by leveraging the losses associated with serving loads on the system. So as Surya had pointed out before, if you're at the substation, so this is outside the substation, there's very little line losses associated with serving that customer. Whereas if you're at the substation and you have to serve a customer that's out at the end of that line, at the very end of the feeder, well, if there's all the line and equipment between the substation and the customer that is consuming that part of that power, which actually adds up to quite a bit, to be able to serve customers at the end of this feeder. So, as you pointed out, that if you're on one feeder, it's pretty trivial exercise to figure out which customers are causing more losses on the system and which customers are causing less. But if you're talking about multiple feeders, in this case we have 8 feeders coming out of 4 different substations, it's not quite as trivial of a problem as it was with just a single feeder. So trying to figure out between one feeder and another which customer is having greater loss contributions than another, then it's a lot more challenging. And so the engine that's sitting behind this tool is called GridFast, and that's what's calculating all these values. So what it's looking at is looking at, of course, the losses. And what you'll notice is I've got a little legend down here that says curtailment suitability. So customers that have high loss contributions we're marking as excellent, and they'll have a little red cherry. So all these little cherries on here represent customers. And so the orange cherries are not as good for demand response, but they're still quite good. Yellow, not as good, and green, you're not getting much back out of it. It's probably closer to a one-to-one relationship. So here, this is all the customers that are on this map. So they're all listed here by transformer ID, and then they're ranked. So this rank 1, that's the most lossy customer, if you will, and all the way through, well, I don't know how many, there's a lot of customers on here. So let me curtail 1 megawatt of load, and I'll show you what that means at the substation. So we're going to curtail a megawatt. So what the system is doing now is it will curtail some load, and then the GridFast engine that I mentioned before will kick in, and it'll do its calculations, and then it'll curtail a little bit more until it gets to 1 megawatt. And then when it's done, it will show you which loads were curtailed. Now, when I say curtailed, keep in mind, that's not cutting the customer off altogether. That's just reducing their usage. So, for an example, at a house, someone might have had agreed to let the utility turn off their water heater during a peak demand time. And so what will happen is they'll send out the signal and they'll turn off that water heater. They're not going to turn off the entire customer, but just rather some selected loads within that customer facility. So here we are. We've curtailed a megawatt of load, and what you'll see is we're not curtailing just on one feeder, because there are several customers over here, these blue dots, on both the orange and the green feeder over here that show that they have higher loss contributions than these orange ones on the blue feeder where all the red was. But all the red got turned off, of course, or got curtailed, of course. But here's the benefit. We curtailed 1 megawatt of load, shows at the substation 1.27 megawatts. So it's 1 1/4 or close to 1 1/3 of how much we curtailed at the customer level. So we're getting a lot more out than what we're putting in effectively. So let me put this back to normal. It'll take just a moment. And what I'll do next is I'm going to curtail just the amount of generation that I want to save. So from a utility point of view, they may want 1 megawatt of reduction in their generation. So to curtail, if they can get 1 1/3 megawatts for 1 megawatt of customer curtailment, then that's more than they really wanted. So they've reduced their generation by 1 1/3. So that extra third, they could be still selling that power. So maybe they really just want to curtail 1 megawatt at the substation level. So what we can do is, rather than curtailing at the customer level, we're still curtailing at the customer level, but where we're monitoring, rather than monitoring at the customer level, we're going to monitor at the generation level. So we will curtail enough load to reduce generation by 1 megawatt, rather than just curtailing 1 megawatt of customer load. So again, it's doing its number crunching. And so what we'll see is we curtailed pretty close to 1 megawatt of generation, and the result is 0.78 of customer load, where all these cherries were blue to start with, because they all got curtailed, and then a bunch of cherries over here were blue, rather than just the 2 or 3 there that are there now. Fewer customers got impacted by this load curtailment. So that way we can get the benefit that the utility needs without impacting the customers, or we can impact the same customers but in a less intrusive way, perhaps. So there's many ways that we could approach this whole thing. But let me put this back to normal one more time. And then another thing that this system does is, let's suppose that we want to just curtail certain amounts of load, and so what I can do is, let's suppose that I want to curtail this customer up through this customer. So if I select all these customers, I can pick and choose which customers to curtail. And maybe the 2 in the middle I don't want to curtail for whatever reason. Maybe they're a hospital, maybe they're an emergency 911 center. There's a million reasons why you might want to or might not want to curtail certain customers. And then we'll curtail those ones manually. So rather than just doing an automatic type of curtailment, we can also do manual curtailments. And then we can see the benefit of that. And so rather than curtailing lots of customers, we only, and once we get that restored. Now, all this curtailment that I've been doing thus far has been pertaining to system losses. Now, as Surya pointed out when he was going through his slides, is that we can also do curtailments based on other criteria. So, for example, we can rank these against, of course we've done them by losses, but let's suppose we want to look at transformer loading. So here's what it's going to look like if we look at transformer loading. So what it's going to look at is it's going to look at all the overloaded transformers, and maybe we want to rank it by transformer loading rather than system losses. So what you'll notice is all those cherries that were red are now green or yellow. There's still a couple of the red ones sitting in there. But then what you'll see is it's scattered out a lot more throughout all the feeders. Particularly over here where you're getting a lot of overloaded transformers. So we can curtail based on transformer loading, for example. There's several other criteria that we could do, but then we can also do multiple criteria. So let's suppose that we want to do transformer loading and system losses, and really get the biggest bang for our buck. In this case, this is of the criteria that we have built into this tool right now. This is where we get the biggest bang for our buck. Okay, so this when it updates, the system will look much more like areas are back on the end of this blue feeder. But let me do a curtailment to show you what the difference is when I do a megawatt of curtailment at the customer level. So again, it's got to do its processing. And what you'll see is, of course, it will have a lot of these red ones will be curtailed over here, but then you'll see scattering of blue dots around the rest of the system. And if you recall, when we curtailed 1 megawatt of customer load, it showed us 1.27 megawatts of generation difference. Well, now by combining the two analysis methods, when we curtail 1 megawatt of load, we get 1.36 megawatts of generation difference, because we're targeting those transformers that are overloaded, and so it's actually giving us even more benefit than when we were looking at just the losses. So rather than the 1.27, which was already extremely good compared to what we've been figuring on demand response programs thus far, I think PJM gives you credit for 5% or 10%, something like that, for system losses. We're getting 1.36 megawatts. So it's 36%, dramatically higher than what PJM will normally provide you. So by taking into account both losses and loading, we really get a lot of benefit. Now, an operational sort of scenario where let's presume that all these customers already have demand response units installed in their houses or in their commercial facilities, and the operator is actually curtailing this load. A planner can also use this tool for planning purposes. When you're planning your DR program, you can take this information and figure out where to target your demand response programs. So if you're trying to sign up a bunch of customers for demand response, of course, you could target market them now. You could look at all the customers on this, particularly at the end of this feeder. You're going to get a lot more bang for the buck, right? So if you target customers on this feeder, you know that one, you'll have to install fewer demand response units at the customer facility, and two, when you do curtail that load, you'll get more benefit on your generation when you do curtail the load. So you can use this for targeting where to deploy demand response types of programs, and where to focus on signing up customers. So if you're going to put a mailer or a flyer in the utility bill, it can go in to the utility bills for these customers, and maybe even reduce the cost of the marketing end of it and the deployment end of it, installing the equipment, and all this sort of thing. So from a planning point of view, this tool can also be used for figuring out where to target demand response programs. So that's what I have for the demonstration